All right, probably my least favorite part of recording this whole course is now I actually have to make myself write a program in instruction lists. So I'm going to come up here and just jump right in. The only way through it is getting it done. So let's create my IL1. Got it. Come into my main program of structured text, and let's go ahead and make a call to IL1. And man, I tell you what, instruction lists makes me actually appreciate structured text. Whew. All right, so here we go. Now, the first thing we need to do is, I know I've got this input value coming in. This is going to be my test val, and I need to add 1,000 to that every single second. So the first thing I have to do then is I have to create a 1-second timer and get that thing updating. So let's go ahead and start by creating an ONESECTIMER 1-sec timer. And I will call that. And let's go ahead and call that a type TON. Got it? And let's also go ahead and get some values in here. So I'm going to LD, and I need to load some time. That's going to be T-pound 1,000 milliseconds. And then I need to store that 1,000 milliseconds into my 1-second timer, and I'll just go ahead and shortcut that, .pt. Okay, so now I've got my 1-second timer actually set, and I've stored the value in there, and I'm updating that all of the time. So this timer is always going to be running. So anywhere below there, I can refer to that timer. And right here, I'm going to go ahead and start looking at if that timer is actually timed out. So now we need a way to energize our timer and reset our timer. And to do that, we want to look at the Q property of our timer to see if this thing is timed out. So I'm going to LDN, which means load the negative of my timer, and I'm going to look at my 1-sec timer.q. So I'm now loading the opposite. So if that's true, I'm loading a false, and if it's false, I'm loading a true. And then I'm going to store that into my 1-second timer.in. So let's look at what I'm doing here. I'm loading my 1-second timer timeout, or my done bit, and I'm loading the opposite. So let's pretend that it's not timed out. Then I'm loading a true, and I'm storing that into the input, so I'm energizing my timer. But if the timer times out, then what I'm actually going to be loading here is false. I'm going to be loading the opposite, and then I'm going to be storing that into my input, so I'm going to be de-energizing my timer. So at this point, I can go ahead and call my timer one more time. So I'll just type in a CAL, pull in my 1-second timer, and the reason that I've got two separate calls is I want to make sure to set my preset before I get down here. Otherwise, I'm going to have a preset of 0, so when I start my timer, it's instantly going to be timed out. Well, I don't want that. So now I've got one call up here to set my preset, and then I've got a separate call down here to actually turn my timer on and make it start cycling. So just like that, I think I've got my 1-second timer, which is going to be perpetually looping. Now I need to use that to update my test value. So I'm going to start by loading test val. Got it? And that's not going to be a bool, that's going to be a real. Okay? And before I even load that, I need to really start working on my timer and deciding how to know whether or not I need to update this or not. So let's start here, and I'm going to load, and I'm going to load my 1-second timer, and I'm going to go ahead and load the Q property of that. So let's load that Q, and if that's true, I'm going to jump. So I'm going to do a conditional jump with jump C, and I'm going to jump into update value, or I'll just call it update val. And then I'll come down here and we'll create that update val label. So update val colon, and in that case we're going to come down here, and now we're going to know that we've finished 1 second, so we need to add 1000 to this. So I'm going to use an add, and I'm going to add 1000. And then we need to know if we are over 16,383 or if we're equal to 16,000, because if we're equal to 16,000, then I know that we need to reset the value back to 0. So I'm going to go ahead and first store this value into test val, and then I need to evaluate. So now I'm going to load, and I'm going to run a comparison. Test val is greater than, and I'll just see if I'm greater than or equal to 16,000. And if I am, then I need to go ahead and reset myself to 0. So at that point I will jump C, jump conditional, and I will go to reset val. And now I can come down here and create a reset val, and this is going to load 0 and then store 0 into my test val. And after that, what do we need to do? Well, now we've got our test val being managed every second. We're adding 1000, and if we get up to the point where we are greater than, or not less than, that needs to be an equal to, greater than or equal to 16,000, then we're going to reset that value and bring it back down to 0. So we're only wanting to do these things when that timer times out. So we're going to need to put in some more jumps later on to make sure that we're not accidentally resetting every single scan and things like that. But we'll get to that once this program takes a little bit more structure. From there, we know that we have our Boolean, we've got our test bool, we'll call it, and that's going to determine whether or not we want to scale every 1 second or whether we want to scale every 5 seconds. Well, first we need to create that scaler. Well, I'm going to go ahead and just call, and I'll call it scale 1, and that's going to be my LIN_TRAFO, our linear transform. And before we scale that, and I'm going to come down here just to give us some space so we don't get confused with our reset value. And anyway, we want to go ahead and set some properties on that. So scale1.in, and we need to set that. So let's go ahead and use a store to store something into that. And before we store anything, we have to load it. And what we're going to load is our test val. Okay, so we're loading test val, and then we're storing that into scale1.in. Then we also need to set our scaling parameters. So let's go ahead and load a 0, and we're going to store that into 2 places. We're going to store that into scale1.inputmin, and then we're also going to store that into scale1. And that's going to be our output min. Perfect. And then we need to load our 16,383 and store that into scale1.inputmax. And last piece of this, let me go ahead and scroll down a little bit so we can get this a little higher on the screen. I hate working on the bottom of my screen. Then we need to load 100, and we need to store that into scale1. And that's going to be our output max. So other than that, is there anything else in here that I see that we need to set? And yes, we also need to set our output. So after that, I want to go ahead and call our scale to make sure that we've updated those values. But then I want to also set our output. So once we've got all of that done, we've brought in our value and we've scaled it. Now we need to worry about when we want to actually update our scaling. So now that we've got all this set up, we actually don't need all of that setup to happen every single time. It's not going to hurt us, but if we go ahead and pull all of this part right here out of there, and I think we can go ahead and just put that somewhere else for the time being. So let's go ahead and cut that. And I'm going to come up here to the top, and I'm just going to paste that in right here. So we're setting our scale in, out, we're setting our output scaling in and out, and then we're using a call just to update that. And we can go ahead and do that every time, or we could put that under an initialization routine, but I'm just going to leave it there for now. And then we need to know when we actually want to update this. So loading the test val and putting that into scale in, then we're going to want a separate call for our scale 1. And after that, we're going to load our test val, and we're going to store that into scale1.in, and then we're going to call scale1 one more time to update that, and then we're going to load our scale1.out, and we're going to store that into our SV. And SV is going to be a real. That's going to be our scaled value. And we need to know when to update this, so we'll go ahead and segregate that and call it update. Now the last piece we need to write is an algorithm that actually defines when we're going to call this update. That's going to be based on a timer, which is either going to be 1 second or 5 seconds, and that depends on the status of our bool. So let's go ahead and create another timer here. And to do that, I'm just going to scroll up here where I know I've already got a timer created. And I'm going to copy all this right here. Actually, I'll just grab everything that pertains to the timer. Better safe than sorry. Better to have too much than too little. Come down here, and we'll go ahead and call this clock, and let's paste that in there. So what is our time going to be? Right now we're putting in 1,000 milliseconds, but in this case we need to check the status of a switch. So we're going to go ahead and load test bool, and then depending on the status of test bool, we want to jump to one of two places. So if test bool is true, then we want to jump C, and we want to go to 5 second time. So I will call this 5 sec, and let's come down here and we'll create our 5 sec. And if we don't jump, that means that this was false, in which case we want to go ahead and set that up as 1 second. So in that case, I can go ahead and copy this right here, and I can paste that in. And then for our 5 second, we'll come down here and we'll set that equal to 5,000 milliseconds, and we'll also update the same thing. So from there, we'll go ahead and come down here and we'll create another routine, and we'll call that run clock. And from here, we're going to jump to run clock. And after 5 seconds, we don't have to put a jump because we're automatically going to come down to run clock next anyway. So we should be fine with that. So what does run clock look like? Well, first thing we want to do is we want to make sure that we're looking at the right timer, and right now we're not. So instead of 1 second timer, we're going to call this var timer because it's variable. And let's go ahead and call that a TON. Good. And this var timer, I'm going to go ahead and paste that over 1 second timer. Here, here, right here, and down here as well. Whoops, I don't know what I hit, but it wasn't what I wanted to hit. Okay, there, we've got that all put together. So let's come back up here and see what happens. When we come to clock, we're going to load our test bool, and if our test bool is true, we're going to jump down to 5 seconds. Otherwise, we're going to stay up here. And if we stay up here, we're going to set the time on the preset to 1 second, and we're going to call it to make sure to update that value. If we come down to 5 seconds, we're going to update that to 5 seconds, store it, and then we're going to update our timer. Then in either case, let's go ahead and just fix the indenture on that. Good. Hey, that's not what I told you to do. What's wrong with you? Oh well. It doesn't want to seem to work, so that's fine. I won't complain. I'll just let it sit like that. Anyway, either way, we're going to come down here to run clock, and we're going to have either a 1 second preset set, or we're going to have a 5 second preset set. Then we're going to load the value of Q, but we're actually going to load the opposite because we're negating our load. So then we're going to store that into the input, and that's going to create our automatic reset. And then we're going to call to update one more time. Then we're going to load Q directly, and we're going to update value based on that. So if we're timed out, then we're going to go ahead and jump. And it looks like we're going to need to load Q actually before we call the timer so that we don't reset that value. So I'm going to cut that out of here and paste that into here. So then we'll go ahead and call the timer to update it, but we've already got our Q value loaded before we do. And then we're going to jump conditionally based on whatever we loaded in that step. And if we do update, then we're going to come down here and we're going to load this. Actually, it's not called update, it should be called update val. And when we update our value, we're going to load our test value, and then it looks like we can take all of this out because I've got some duplication in there. So let's yank that. We're going to then load our scale out and store that into our SV. And the only thing left that I think I need to do, I think I need to put returns in here. I don't need to put a return there. Let's go right back up to the top and figure out where we do need our returns. So we always want to come in and start by running all of this stuff up here. When we come down to update value, we do want to always do that. And actually we've got two things called update value, and we don't need that. So let's see, what's this first one? This first one right here is update val. And we will go ahead and take that. But then this last one down here, we're going to call that update SV. So let's go ahead and change that name. There and there. Perfect. So we're going to jump to update SV, and just in case we don't jump, we're going to return. And after our 5 seconds, we're going to run into our run clock anyway. So we're always going to run into our run clock. It's just a matter of a decision whether or not we're going to update our SV. And I think at that, I've got this program written, unless I'm just massively forgetting a bunch of stuff. So let's go ahead and call that a draft. I'm going to just give one check on build to make sure I don't have any massive errors looking at me. And assuming everything's good, it's not. let's go into 26. And what's the problem here? We're expecting an end of instruction list before greater than equal to. So what I have to do, I can't do a load and then an expression. I need to do GE, which is greater than or equal to. And I'm going to compare test val to 16,000. That should solve that. Then in 33, we see clock is no function. So let's go down there, and clock, apparently it doesn't like the name clock, or it's because I actually don't have a jump to it. I need to go ahead and JMP, and I need to go ahead and go straight to clock. So I can put that in there and back that off, and I think that'll solve that problem. Then down on rung 51, I have accumulator is invalid before conditional statement. So let's come down here and see what we've got. So I'm calling my variable timer, and apparently I have to load this thing and store it somewhere first. So I'm going to go ahead and store that, and we will store that as, I'll just call it to jump. And that'll be a bool. And then I can call my variable timer, and then I will load that to jump. And that should have it. So let's try this one more time. Project build. And still have label clock is not defined. And I think that's because I've got a semicolon at the end of that instead of a colon. So let's try that one more time. And project build. Clock is no function, so it still doesn't like that. I'm just going to go ahead and put a 1 on that and see if maybe that's some kind of reserved word that it doesn't like me using. Let's try that again. Yep, it just looks like it doesn't like me using that name clock. Then in rung 40, I've got a problem that I'm jumping to run clock. I've got an end of IL statement. And that's just a matter of I've got a colon here, and I don't need to have that colon there. All right, so now I think I've got something that'll build. And perfect. We're going to drop off here. That was a nice and long session, and we're going to come back in the next, run this thing up. I'm sure it's going to have plenty of bugs. It's going to be infested. So I will be squashing them and trying to turn this into something that actually works. So I'll see you in the next.